Today we're going to walk through the basics of head tracking in SynthEyes and export the scene to a 3D package for further work. Let's dive in! So this is the shot I'm gonna work with. I recently watched the Netflix show 3-Body Problem, so I thought it would be cool to add a CG model of a shiny helmet like the one shown in the series. And to do that, I first need to track the motion of the actor's head. Luckily, we have enough details here to be used as potential trackers. But I'm too lazy to create them manually. I want SynthEyes to do that for me. However, I can't just click Run Auto Tracker button, as that would put trackers all across the shot, both on the background and on the actors, treating them as a single object. That won't resolve in a good solve. And I don't want to scrap through the shot and manually delete them either. My shot is only 10 seconds long, but imagine doing this for a much longer sequence. So here's what I would do instead. I would undo the changes to delete all trackers and head over to the roto masking room. Here on the left panel, you may notice a new button labeled MaskML. MaskML is a new module introduced in SynthEyes 2025, designed to help you create garbage mattes for tracking in seconds. We have another video on our channel dedicated specifically to MaskML created by Kelvin. Check it out for a deeper look. But for now, I would make a selection for the actress with a few clicks and run the mask propagation. When the mask propagation is complete, you'll hear a notification. That's the sound of success. I can close the dialog now. By default, all layers created with MaskML are automatically set to be used as garbage mattes. But we actually don't want to use this alpha as a garbage mask. Instead, we want to tell SynthEyes to solve the motion in this area as a moving object. So I'll go to Shot, Add Moving Object. And now, in the drop-down menu below the layers list, I can assign the newly created layer as a moving object. With that set, I can go back to the summary room and click the big Auto button. Okay, here's our first solve. The tracker's point cloud already looks like a head moving in 3D space. We're getting somewhere, but let's make it better. We do have a subtle camera shake in our shot, but we really could just ignore it and solve the scene as if it was a static camera, since it won't really affect what we need the head track for. So I would clear the solve, set my active trackers to the camera, disable the camera motion here, and solve it again. Now only the trackers assigned to the actress has been solved. Our hpix error is now 4.3, which is quite high. Let's switch our active trackers back to object mode. Since I really only care about the head motion, I can simply select the trackers that appear to be outside of the head and delete them. Now I'll change the solve technique from automatic to refine and click go. The solve error has improved from 4.3 to 1. Lastly, I would run the tracker cleanup. Choose bad frames, toggle disable and click fix. Then refine the solve again. The hpix error is now down to 0.7, which is great. Now we can follow to the 3D room to align the head mesh. SynthEyes 2025 comes with a built-in base human head mesh, available in 3 LODs: high, mid, and low resolution models. So let's pick one of those in the mesh selection drop-down menu. I'd go with a high detailed one. Then click and drag in one of the 3D views to create the mesh. I try to place it somewhere near the center of the tracker's point cloud. I use SynthEyes' standard transform tools to roughly align the mesh to the actor's head. You can quickly cycle through them using the W, E, and R keys. Since this is just a generic mesh, it won't be a perfect match to the footage. For now, we just need something that looks good enough. We'll refine it in the next step. I press F3 on the keyboard to change the perspective layout. Before making any further adjustments, let's declutter the viewer a bit. So I right-click in the viewer, go to View, and choose to show only locked. Then right-click again and hide the handles. We can also hide the trackers by pressing J on the keyboard. Lastly, I find seeing the inner parts of the mesh a bit distracting. So what I can do is enable the occluded wireframe option. Now we only see the polygons that are facing the camera. Actually, I can completely cut off the parts of the mesh that I don't need at all, since I'm only interested in having the head geo. So right-click, Mesh Operations, Lightsaber Deletion, and just lasso select the polygons that you want to delete. That looks fine for me. Now we're getting into the fun part. To match the mesh more precisely to the actor's head, I'll use the Smudge Relax tool. So let's enable that toolbar. Here's how I prefer to work with it. I set the brush to a very small size, then make sure it's affecting only the surface, and toggle softly yes to enabled to make smooth adjustments. Now I can click on a mesh directly in the viewer to match it to the imagery more precisely. Then with the mouse scroll wheel, I change the range value that controls what parts of the mesh are being affected. It almost feels like sculpting. So with the Smudge tool, I scrub through the shot and fine-tune the mesh. This is an iterative process that takes time, so I'm going to speed up this part. I've spent some time adjusting the mesh and I'm happy with how it looks. It will work for what I need. Now let's export the scene to the desired 3D package. Houdini is my tool of choice. SynthEyes offers a variety of export options, which can be confusing at first. Although SynthEyes has a dedicated option to export a Houdini script, it won't work for me in this case as it won't carry on the geometry we've set. So I would choose something else like Alembic or FBX. The only thing I would change here is set my scene scale to 0.1 and change the marker type from Crescel to null. Everything else I leave on defaults and save the file. Now in Houdini, I go to File, Import, FBX, and choose to import with this set of parameters. And here I get the whole setup, including the camera, nulls, geometry, and the camera backplate. What I usually do next is connect another geometry node directly to the head mesh. Then I replace the default cube with the desired 3D model and align it based on the reference geometry. Then I set up the material and lighting, and we're almost ready to render. I've set the head geo to be used as a matte object to cut out the backside of the helmet, which shouldn't be visible to the camera. I also created another render path and set the head mesh as a shadow catcher, so it will help me blend it better later in Nuke. I hope that gave you a nice overview of the head tracking process and a clearer sense of why you'd want to export not only the moving object null, but also the reference geometry. Leave us a comment and let us know what you'd like to learn next. My name is Elizabeth Postol for Boris Facts. See you in the future videos!